In early February, we joined about 75 other power users of Emulate3D in Salt Lake City for a 3-day event to share stories, network, and learn about some new features. It's one of the events that I've been attending since about 2013. It's a great event, and I enjoy going every year. And my favorite part is hearing stories from other users so we can incorporate some new ideas in our practice. So I wanted to share my top 5 favorite client presentations from the user group meeting. And starting with number 5 is from Paul Christensen, who is a newcomer to the Emulate3D conference, but he gave a couple really cool presentations. And the first presentation he gave was about training computer vision using NVIDIA's Omniverse and Emulate3D. So Paul is from a company called Project Binder, which is out of Denmark. And his presentation, like I mentioned, focused on training vision systems to detect anomalies. And they were doing that for vaccine vials. So some very high precision, a lot on the line type of testing. It was very cool. So his team used Emulate3D to create known flawed vials and then used high quality renderings from NVIDIA's Omniverse through a connection to basically train the computer vision model on what bad vials looked like and what good vials looked like. And then once it's trained, his team could basically test how well the computer vision predicted anomalies, make tweaks to the computer vision system, and continue iterating until they got something they were comfortable with. The best part of his presentation, I thought, was how it removed a ton of critical time and energy and product in the field that would otherwise be required. So, of course, you're always going to have things in the field that need to be tweaked, but I thought this methodology was one that seemingly saved a considerable amount of time and effort and apparently proved to be very valuable to his client. So it was an excellent presentation from Paul. Number 4 was one that focused on saving hundreds of thousands of dollars during startup. So Sean Chaney was from Pearson Packaging, and he's been a regular at UGM. And he was kind enough to share a story about one of his high-value clients who had a really complex packaging application. I want to say it had at least a couple, if not a few, robots. And Sean's been an evangelist for a long time. And as part of his presentation, he showed how they found several opportunities for improvement in their design, and many of which were revealed using the high-powered physics engine with Emulate3D. He really put our math skills to the test, but by our collective estimation, using these tools helped his client and his team save hundreds of thousands, if not millions of dollars during real-world commissioning by avoiding downtime, which could otherwise be used as productive time. So I thought it was a really cool presentation from Sean. Number 3 was from Eric and Scott from Honeywell. Eric and Scott are also veterans of the UGM conference, and I always enjoy catching up with them. This year, they gave a really awesome presentation on how they drastically reduced the lead time from concept testing to simulation testing, all the way to emulation in a matter of minutes. Being at Honeywell, they can take advantage of their refined standards to build automations that absorb some of their data and then allow Eric and Scott's team to basically automate a lot of the configuration process of their tools. They also demonstrated a tool that they developed to help look for anomalies or errors in some of their standard internal engineering deliverables, which apparently, according to them, and I believe it for sure, has helped them capture potentially big issues that would have otherwise been overlooked through a lot of these big, deep, complex documents. So it was just a really neat presentation from Eric and Scott. Number 2 was from Saurabh from Amazon. Saurabh gave 2 really cool presentations, but my favorite they were both my favorite, but the first one was an automated way to test for chute design for product handling issues. So essentially what Saurabh and his team did was build a cloud-based tool that had Emulate3D in the back end, and it allowed users to run thousands of randomly generated packages that the user could configure down some potential or some prospective chutes. And really what they were looking for is to see how well would the packages be handled, what was the rate of mishandling packages, would they fall off where they weren't supposed to, create jams. Like I said, he and his team created this tool that he could deploy, I assume, internally to his team and allowed them to test for issues. But I think the coolest part of this was that his tool at the end of a run would export pictures and videos of what happened. So if there was a product handling issue, maybe an hour and a half into his run, he developed a tool that would basically detect that, take pictures of what happened, and in some cases export videos of what happened too, so somebody wouldn't have to manually recreate that instance. His second presentation was also a really neat application. It was a computer vision application where he and his team basically used high resolution images to test and train a new high-speed singulator without really requiring any real-world product. So basically what happened is they were taking pictures of packages as they passed into this simulated high-speed singulator. Those images were relayed to actually a MATLAB instance where there was some complex trigonometry algorithms going on, and then it reported back to Emulate3D in nearly real time, but certainly fast enough to do it in real time, with instructions on how to adjust belt speeds such that packages got rotated properly, singulated properly, and basically moved in 2 dimensions such that they could be handled downstream in a singulated fashion. He and his team were able to develop and engineer this new concept really quickly, really cost effectively, and seemingly, again, without having to do that kind of testing in the real world. And then my favorite presentation, or at least number one on this list, was from Andy Cannon from ATC and Laura Green from Hire, which is GE Appliances. So this was a really awesome presentation because it included both the supplier and the end user as presenters. They demonstrated several applications of automating assembly lines for household appliances like dishwashers, and I was especially impressed with how open and receptive both ATC and GE were to changes. Oftentimes, simulation and virtual commissioning calls out issues that may reflect poorly on engineering teams, but everybody's human and everybody makes mistakes. And really what this technology allows us to do is find those issues sooner, iterate faster, and ultimately deliver high quality automated systems that work for a long time. So I could go on and on about the presentation and how much I loved it, but just one technical point to finish out. There was a really cool part of their presentation where Andy's team found an issue with how items were being packed into a tote container, basically dropping in from a conveyor belt. And his team realized that adding vibration to the tote would permit the items to settle and collect more efficiently, thus increasing the number of items that could fit into the tote and reducing the number that ended up on the floor. So it was just an awesome display of technical expertise and high-powered physics engines from Emulate3D. So as you can tell, it was a great conference. I had a great time, and I appreciate you watching, and we'll see you next time.